Everybody, thanks for coming out tonight. As Bud mentioned earlier, my name is Jeff. I have nothing to do with Roots. that is another Jeff. But I am on Google's developer relations team. And I spend a lot of time thinking about service workers and progressive web apps and kind of all those buzzwords that you probably heard quite a bit about. So I think one of the things that we have done a pretty good job of talking about in terms of Google's developer relations team is like progressive web apps as replacements for like apps, for things that you would normally like go to the Android App Store or the iOS App Store and like install on your phone. And they're more appy and less about consuming content. And that's great. Okay, we've spent a lot of time talking about that, but I don't think we've spent, on my team at least, as much time talking about what it means to kind of have like a progressive web app, or let's just say an offline first experience for something that's a static site, or something that's more about the content and less about an app. So I've been thinking a lot about that. I've been kind of just playing around with some different techniques and taking a look at what other people have built, thinking about pros and cons of different approaches, and I wanted to share some of that with you. So as Bud mentioned, I recently wrote up some thoughts. This was a really nice forcing function. Speaking here is like I want to get all my thoughts down in a blog post, obviously, and have it kind of fresh in my mind and talk through it with you all. So I wanted to, before I get into too much of the different techniques, I wanted to kind of deal with some terminology, make sure that folks are comfortable with what I'm going to be talking about from that perspective. So first, I want to start with what's a static site. Hopefully this audience does not need me to spend too much time talking about that. But I'm basically thinking about things that might be blogs, things that might be news sites, things that are some combination of like taking some sort of layout template, taking some sort of content, regardless of where it comes from, kind of like smushing them together, and you have some actual HTML pages. Very, very generic diagram there for the smushing process. I'm personally, not really concerned with what the actual, underlying architecture you're using for your site is. The concepts I'm going to be talking about should be generally applicable to all sorts of different backends, whatever is actually like in those boxes, whether you have your content as like markdown files, whether your content is coming from a database, whether your template is written in handlebars, XYZ, doesn't matter too much. But let's just assume that this is a general idea, though. You have your layout, you have some content, smush it together, get HTML. Your users view your HTML, your users are happy. Hopefully, most of the time. If they have a good connection, they're happy. So what do we mean by offline first then? So I think that, let me just put up this screenshot from my colleague Jake Archibald, who you can't really give a presentation that touches on service workers without referencing Jake. He's very involved in all the different specifications and best practices and stuff like that. So this is how he phrased it, and I think he did a really good job there. But I think the basic idea behind offline first is that you want to avoid going to the network when you can. You want to ideally have data locally on machines, or devices or mobile phones, whatever is running your web browser, and you want to go to that whenever possible. If you don't have the data that you need in order to display a given URL that you've navigated to, okay, go to the network, that's fine. But you try to go to the local storage type situation, whatever you happen to be using for storing your data first. Sure.
This is not what many modern commercial sites do.
Mm-hmm.
If you go to weather.com, you find out the weather today.
Yes.
It goes through 50 different files, different things that it tries to connect to, and it's a pain in the...
Mm-hmm. I'm not going to comment specifically on weather.com. I think actually, well, let me comment briefly on weather.com in that, like, at the last Chrome Dev Summit, which is like our developer event that my team puts on, we were talking about weather.com's journey. And there are folks at sites like weather.com and sites that are maybe a little bit heavyweight right now who are really thinking about this. And a lot of them are thinking about it from the perspective of progressive web app, maybe a little less about the content stuff and more just like specific functionality. So that's definitely part of it too. Like the whole app experience of like opening something up and expecting it to just show you the weather. Maybe not reading all sorts of articles, but just show you the weather. So that's definitely a valid use case for service workers. And like I said, we spent a little bit more time talking about that in some other events, but I wanted to focus on like, what does it mean like if you want to go to a site that has a bunch of different articles and different content and different URLs, and how do you take that offline first? So this is all really new. I definitely don't want to, shame people for not adopting any of these practices yet, and we want to kind of talk about it and get people comfortable with them and figure out what the best approach is. So, yeah, offline first is basically just avoiding the network whenever you can. And service workers definitely help with that, but we'll get to that in a second. But first, why offline? Why do you want to avoid the network? Two reasons. People very frequently will talk about the scenarios where you don't have device connectivity. That's certainly one. It's nice. I used to say to be on the subway and be able to pull up stuff. Subway cell service and Wi-Fi is actually pretty decent now in New York, so it's a little less compelling. But like when you're in between the stations and all those other times when you really don't have a good mobile connection, it's nice for things to continue working then. But even when you are online, there's this kind of like, this is kind of a number that I pulled from just taking a look at the network traffic for navigating to the top level page on a like simulated 3G connection for just a basic site. And this is actually pretty good. Having 423 milliseconds going against the network, getting back 6.2 kilobytes. It's not bad. It could definitely be a lot worse, but it's also the case where that could be, instead of 423 milliseconds, it could be 10 seconds, it could be 20 seconds. For folks, especially folks who are not in areas with really good mobile connection, you really don't know what the latency that the network is going to add will be. It's an unknown. And this is for the content that's really not cacheable. This is like the top level or the initial navigations that you have to the site. There are lots of ways of doing like just traditional standard HTTP caching techniques to make sure that all of like your sub-resources are versioned and properly cached, and that's great, and people should still do that. But you still have the problem of like that initial navigation to your getting the HTML document that has all those version resources. That really does need to go against the network, and you don't know how long that's going to take. So being able to have a reliable, this is going to take, like in this case, it's take 5 milliseconds using the service worker approach, but it's going to give you kind of a known quantity as to what this speed is going to be. It's not going to vary wildly. So that's really the offline first. It's not just when you don't have a connection at all, but it's reliable performance when you do have a connection. All right, so I mentioned a little bit, it's come up a few times before. What's a service worker? This is a huge topic. This is something that I can and have easily dedicated entire talks to. So I'm unfortunately not going to spend a huge amount of time talking about generic concepts about a service worker, but if there are folks out there, actually maybe just show hands. Have folks used service workers before? If you could raise your hand. Not everybody. Okay, so maybe I'll spend a little bit more time trying to explain what's going on, but high-level picture of what a service worker is and why it's important. Service workers are this new piece of functionality that's been added to a number of browsers, not just Chrome. Firefox has them as well. As of right now, Edge is developing support for it. I don't even have an outside line. No. No. Yeah, unfortunately I don't. And the question for folks who couldn't hear that was just about Safari support. Safari does not currently support service workers. I don't really have any insight as to when that might change. All right, but so what is a service worker? It is basically acts as a network proxy. So it has it has the kind of the property of sitting in between your pages and the network. And whenever your page is making a network request, either the initial request to navigate to your page or like when you're loading images or anything else, the service worker gets first shot at it, basically. It could respond to that. And you do that by writing JavaScript. And this is like all event-based JavaScript. So for instance, there's like a fetch event where whenever there's a network request made, that fetch event gets fired in your JavaScript code and you could respond to it however you want. And that involves like being able to go against caches, and there's not really part of the service worker spec, but there's like a separate cache storage API that the service worker has access to that gives you a really nice control over being able to, like, separate from the browser's HTTP cache, like have complete control over the resources you're caching and the responses that you're caching and use them as you see fit. And it runs in your browser, as I mentioned. So this is, not something that you deploy to your server. This isn't running like on a CDN or anything. This is code that gets installed and registered and persists in your browser and takes control over your entire site or a subset of your site. You kind of, during the registration phase, get to say, okay, I want the service worker to start intercepting requests for like everything that's underneath this given path, which is called the service worker scope. So theoretically, you could have it take control of your entire site. We see some folks do is just have it service worker take control of a subset of their site, and if they're like have some legacy stuff that they're migrating over and they don't want the service worker to touch, you could just have, assuming you have clean URLs, you can kind of just take that approach too. But yeah, so that's the service worker. I'm going to kind of dive in and show some examples of a service worker in action. So hopefully that will clear up some more things. But are there any questions about general service worker concepts before I go on? Sure.
Have they replaced and or obviated the need for web workers and or index workers? Are you like using those terms as well anymore or not?
I'm not sure what an index worker is.
Wasn't that the first iteration of web work?
I don't, maybe. I know, so from the web worker perspective, service workers are different than web workers in that, first of all, okay, this is how service workers are similar to web workers first. They have access to things like the cache storage API, which the web workers do now as well. They have the ability to pass messages between the page and other clients if they want. But just like a web worker, they do not have access to the DOM. So service worker kind of behaves similarly in that it could create things and then like pass a message back, or in this case, respond to network requests. But you can't like directly manipulate the DOM from the service worker. Service workers are different than web workers in that they have different lifetimes. So web worker kind of, you as a control page, you spin up and you say, I want this basically to run in a different thread and do whatever and then pass the message back. With a service worker, the browser takes care of starting that up for you even before you navigate to your page. And that means like that initial navigation after your service worker gets registered will be under control of the service worker, and then you could like, serve it from the cache, for instance. So that the lifetime is different, and those registrations persist. So the first time you visit a site, it registers a service worker. That service worker is going to be available, a week later when you come back, because otherwise it wouldn't really be that useful. Like, if you have something that works offline, but only when you have the tab open and you close it and you come back and everything stops working, that's not really the experience that people expect. So main difference is persistence, probably. And then you have access to these events, like fetch events, and being able to intercept network requests and things like that, which are not at all available to web workers. So they're complementary because you still do have web workers for specific tasks, but not really the same thing.
Sorry, just one more. Are you always in control of the deregister process, or is the browser always in control?
So I mean, the user has the ability to clear out service worker registrations, similar to the way that they might clear out the cache. Like the kind of the flow in Chrome, at least. I'm not exactly sure about Firefox, but like the flow in Chrome where you basically clear like all storage for a given domain if you like click on a lock or something like that. That will also deregister the service worker and clear out your cache and stuff like that. Traditionally, though, if you are just like upgrading what your service worker does, there's kind of like a flow that will take care of it for you that doesn't necessitate people manually deleting it. Like ideally, as a developer, you will do something intelligent, even if you have to completely change your service worker. That doesn't involve like telling users, hey, unregister this and then register again. So, cool. All right. So I kind of want to present this, and this is very similar to the blog post for folks who did read this, as kind of just talking about some high-level options and 3 different approaches for taking all those primitives that we talked about, taking the idea that you have the static site, it's built from all these things, you have service workers, you want it to start working offline first, you want to get all those benefits, you want to avoid gotchas. You still want to have a site that works, because I don't want to scare anybody off from service workers, but you have a proxy that you're running, that you're responsible for writing the code for, that sits in between all the network requests. So there are different ways you could do the wrong thing in a service worker and make your site not behave the way that you would expect it to. Not have updates come through when you would normally expect them to come through. There are some things to avoid. So I'm going to touch on those too and talk about kind of the drawbacks of certain approaches. Okay, so first approach that you might take, and I don't want to also put value judgments on any of these. These, I think, are 3 equally viable approaches, and think about what works best for you if you want to adopt one of them. So the first option is kind of full page caching. That's what I like to call it. And so the basic idea is those final HTML files that you had as a result of like smushing everything together, those are what's going to be stored in the cache in this particular case. And every time somebody navigates like foo.html, the service worker, in a pretty straightforward way, will kind of look up the cache entry that corresponds to that specific URL. Assuming that there is a cache entry for it, it'll just spit that back out. That's the general idea. I want to run through kind of what that looks like in practice. This is one of my colleagues. Excuse me. This is one of my colleagues, Paul Kinlan, who has a blog that implements full page caching. So hopefully he does not mind us poking around. And what I'm going to do, and this is a very useful tip that kind of works around something that you might run into when you're developing locally with service workers. I like starting fresh in an incognito window all the time. The way Chrome does this, Firefox is unfortunately a little different, where Firefox privacy browsing mode does not let you do service workers at all. But in Chrome, it does let you register a service worker that'll go away as soon as you close the incognito window, but it means you could always start fresh. Every time you open a new incognito window, you don't have to worry about the service worker being installed already or anything legacy being in your caches. So it gives you a nice view for debugging, this sort of thing. All right. So I did not do that. All right. So what I'm going to do is pull open Chrome DevTools over here. And all right, I'm going to just start by going to the network tab. I really love doing this. I think this is the best way to figure out what's going on whenever you're dealing with service workers or anything else. Yeah?
One more thing to add into the incognito piece is if you are profiling the way that I assume you're about to do, and you have any Chrome extensions, they will add their JavaScript signatures to your profiles, which can really skew your script flow tabs and stuff like that. So
Sure.
that was something I found out the hard way pretty early on. It's why are all the pages taking so long to load? It's like empty JavaScript
It's not your fault.
file. It's still taking like half a second to load up. So it's another just important piece of code nothing. So
Cool.
there's a bunch of sections.
Cool. All right, so I'm going to navigate here. Let's just take a look what's going on. I know this is going to be too small, so it's nice because you could actually make that part bigger. All right, so we have a web page. Has this kind of top level navigation. You have some HTML. It returns. This is actually nice. This application tab in Chrome gives you a view of pretty much like a unified view of all the things you might need when you're building a progressive web app. So this is like your web app manifest, your service worker registration. You could confirm that there is actually a service worker registered. If you as a developer want to clear out some things, you could use this. Again, I kind of don't like using this. I like starting fresh with incognito, but you could use that. And this cache storage over here, which we'll get into soon. So one of the things that gets a lot of people about service workers, the very first time I navigate to the page, the service worker isn't active yet. Service worker it gets registered by the page after you visit it the first time. So it's really the second time that you visit a page that the navigations will be controlled by the service worker. So there's really nothing going on like in the cache right now. But now that we have an active service worker, and we can confirm that over here, sw.js, if I navigate around, it'll start being controlled. And we go back to the network tab. So you can see over here, this loading web components right here was requested, and that's great. This is just full HTML. And if I go over to the application tab, what's going on is this gives you a view of the specific cache that service workers have access to. And you can see all the stuff that Paul's service worker is caching. So we have a bunch of PNGs that get cached, but we also have this loading web components entry over here. And this corresponds to the actual HTML that we just saw. Let me show you a quick tip if you want to. So this is a little bit farther along than the early days of debugging service workers and figuring out what's happening. But there's still no way to like view the contents of the cache. So let me just show you a quick way of doing that. You do caches match, which is just using, I'm in the JavaScript console now, just using the same sort of JavaScript that you would do from like an actual service worker. And then that is going to give you back a response for that cache entry. And then I could do then response and then do r.text. And this is going to give me the actual text of the response, and then I'm going to console log it. So we have that. So main thing I wanted to show here, though, is that this is just the same HTML that previously came over the network. So you basically have a situation where your cache is storing the full HTML documents one by one. Okay, and just to show that it also works, if I go offline here, reload the page, everything works fine. Sure. So the Fetch API has primitives for request and response objects that the cache storage API also uses. So it is very similar. Exactly. But it comes in handy when you're writing your own service worker code because you have a fetch handler, and whether it's coming from response is coming from the network or whether the response is coming from the cache, you have these same primitive response objects that you pass back and forth. So yeah, and it's all promise-based. If you've, unfortunately, again, I don't have too much time to get into like all the service worker nitty-gritty, but it's all promise-based, and that's why those thens are there. All right, so anyway, we have this approach. Hopefully I've convinced you it is caching full HTML pages, and it works offline. And that's great. And what it's actually also doing is caching on demand. So it's not like pre-caching a lot. It's when you visit a page, it gets added to the cache. I can take a really quick look at the service worker code that he's using, but honestly, I'm not super familiar with all of it in advance. I think he's using this he wrote his own router. So it might not be super representative of generic service worker code, but that's the strategy that the service worker is using. Sure. No, please. That's why I'm here.
I noticed you said he isn't pre-caching anything, but if you did want to pre-cache something, I know that that's something that is a possibility. It's something that you guys have worked in libraries for. Is there anything else you can tell us about that? Just because.
Both of the next two options will cover that. Yes, totally. So yes. All right, so we have that example. That's kind of what it looks like. Let's talk about why you might want to take this approach to implementing offline first. First of all, service worker simplicity. with the caveat that nothing having to do with service workers is super simple, but once you kind of do learn the basics of service workers, it's not too hard to envision how this would work. You kind of have a fetch handler that will make a network request if there's nothing in the cache, and then try to keep your cache up to date via some strategy. But you're basically dealing with just kind of translating network requests and either sending them to the network or sending them to the cache. So nothing super, super crazy. We'll get into some more crazy stuff soon. There's also kind of minimal deployment overhead. So I think with this type of approach, you do have to write a service worker. You do have to kind of deploy the service worker script and add the code to your pages to register it. But other than that, you're not changing too much about your site. Like it's what the service worker deals with. It's pretty much the same things that the browser would be otherwise fetching directly. So you have the full HTML documents. You have like the PNGs and things like that. So you don't have to change much, and it means you kind of just drop in this approach, especially as a kind of a first or quick service worker. When you really do want to get something going, it's very satisfying, for instance, to take this approach. So I mentioned the fact that it's not deploying anything extra. That means there's no content duplication. Like it has, I don't know what Paul is using to generate those final HTML pages. I'm not sure if it's Jekyll, I'm not sure if it's something else. But whatever it is, there's no like 2 copies of your content sticking around anywhere. There's that HTML, that's the authoritative source. That's what ends up being cached by the service worker. That's what ends up being requested by the browser. Nothing's getting out of sync, ideally. And it also works well with multiple layouts or multiple kind of just templates or certain sections of your site that aren't templated, which I'm sure folks out there who actually work with static sites on a daily basis are familiar with the issues involved in like knowing which template to apply to which type of URLs and that sort of stuff. And you don't have to think about that in the service worker in this case. The service worker has a URL, points to HTML document, it's going to cache that HTML document, regardless of what template was user generated or what. So that's actually quite nice. So some drawbacks there. One of the drawbacks, which may or may not be an issue depending upon how your site is structured, is that there's a certain amount of overhead that is introduced with this type of caching. So you take a look, at this. I'm just going to pull up the HTML over here. There's a bunch of what you would expect from any sort of templated site. There's all this head information. There's probably some footer stuff down there. There's some styles that are inlined. The thing is, every page is going to have that same information in the current, in this current approach. And it's not huge. It's text. I don't know if it's 500 bytes. I don't know. Maybe it's 2 kilobytes. It's something. That's probably not going to make or break your users and the amount of storage you're taking up. But if you're dealing with the situation where maybe you have 2,000 pages on your site and you're doing the strategy with each one, and there's like 2K of overhead. Okay, you're wasting some space. That's not the biggest thing. That's not the biggest thing. The biggest thing, though, that you need to watch out for with this approach is that updates are very messy. And what I mean by that is folks tweak their site templates all the time. You change, maybe you change some inline CSS, maybe you change the text in your header, maybe you add some extra information to the footer. What happens in the scenario when you do that? Well, what happens depends upon how diligent you are in going back and cleaning up all the old stuff, basically. So kind of the worst case scenario of what happens is that you make your changes. Maybe it's a really important change. Maybe you change your phone number, contact phone number, or your contact email or something like that. You really want those changes to get out there. You deploy it. You don't do anything else. And then every new page that your users go to, you have a brand new user, or if you have an existing user and they go to a new page, they will see that updated information. But everybody who has something in their cache already, they're going to continue seeing that old page unless you have some strategy for dealing with updates. So there are ways of dealing with that. One is to do kind of like a stale while revalidate for all your navigations, where every time You visit an HTML page, you serve it from the cache first, and then in the background, you fetch from the network any latest update. And that will work. It means that the next time a user visits your page, that specific page, they'll see the new content. Assuming that there is a next time that the user visits a specific page, because like if they go to your page once, they get the cached copy, they call your phone number, and they get a wrong number. Not everybody's going to think to reload. Some people do, though. So that is one way of dealing with it. Another way of dealing with it is just saying, okay, every time I make any changes to my blog template or whatever my master template file is, I'm going to blow out everything that's currently in my cache. I'm going to take all my HTML, I'm going to delete it. And that means, people don't have to worry about getting stale content in that situation. And you don't have to worry about going from one page and seeing one background color and to another page and seeing a completely different one and back and forth depending upon what's cached or not. But what it means is that all the work that you've done to kind of do this runtime caching and build up your cache, if it's going to get blown away from your users' devices every time you want to tweak your template, you're kind of missing out on the benefits of being offline first. Like offline first is only effective if you know that you have data in your cache that you could trust, and you know that it's going to kind of, you don't have to have a mental calculation. Is it really important to make this one tweak if I know that everything that people have been cached, and this is just for runtime caching. If you're pre-caching stuff, it's even worse because you know that there's always going to be like 10 pages in everybody's cache the second they visit your site. You really don't want to blow all that away and keep re-downloading that every time somebody goes to your page. And sorry, there was a question.
How are you busting the browser's cache when you make the tweet on your site?
Most people don't know that you need to do that. You do need to do that, even from the service worker when it's doing pre-caching. So if you use a library that I've written called SW Precache, it will do that for you without you having to realize it. This, unfortunately, is like, I kind of, like my insides get really nervous whenever I see a lot of the examples for service workers that are floating around the web where they show pre-caching, and it's like a list of URLs that are unversioned URLs, and it's like, add this all to the cache. And part of it is we have not done a great job of explaining the fact that the browser's cache is consulted when you request those URLs. And you do need to cache bus those if you want to make sure you're getting something fresh, basically. Or if you have a sane caching strategy already and your URLs are all versioned already and they have the hashes from Webpack or whatever versioning, then you don't have to worry because those things aren't going to change. But it's really for the stuff that's unversioned where you might not realize, like GitHub Pages, for instance, makes everything, serves everything with a 10-minute cache. You can't control that. You could really, really screw yourself over if you start pre-caching unversioned stuff that's served by GitHub Pages and you do a quick update. A lot of times you're screwing yourself over because I don't know how popular your site is. Not everybody's going to go within 10 minutes and try it, but you're developing stuff locally and you're like, I thought I made these changes. What's going on? And it's because the browser cache actually does come into play and can kind of pollute your pre-cache. So that's something separate. I'm very biased, but I recommend using SW Precache to handle that because it'll take care of that for you. Sure.
If you were generating a static site that could put out essentially a list of files that were changed since the last deployment, do you guys have a library or some kind of tool that would set that kind of list and partially invalidate the service workers?
Yeah, so right now, the tool that we have for pre-caching is SW Precache, which tries to version things itself based on, after you've finished your build, you have all your final resources, it'll generate hashes for those. We're working kind of like the newer generation of service worker libraries, because kind of the history for this, like I started working on this like 2 years ago. JavaScript's changed a lot in 2 years. And we're kind of working on a newer, more modular approach to the whole set of like pre-caching and runtime caching. And our new pre-caching module kind of takes in a manifest from whatever source, and we're trying to be a little flexible about what sources we will read that from. But definitely be interested in talking about like what you're outputting and see if we could read that as a way of triggering the updates. Because that's the other thing. You only want to download things that actually changed. Like all these strategies can really save a lot of bandwidth if you're doing things like making sure that you only re-download things when they've changed. You're doing things like reusing stuff, preferring to use the cache version and not having to do those. Like that's still well revalidated in the background. You're using bandwidth that theoretically you don't have to use if you have a different strategy. So,
how long will local cache content persist?
yeah, it persists pretty much I don't want to say indefinitely, because if you are in a situation where the device itself, where Chrome or Firefox sees that there is storage crunch, or just low storage, it will start evicting things, but it will start evicting things on a per origin basis. So it's kind of all or nothing. You won't just have some entries disappear and others remain. So this is actually something that's a little bit different than like browser caching, where the browser caching, you don't really get all those guarantees, and even if you have your perfect browser caching header set up, things just disappear from the browser cache. You don't have to worry about things just disappearing one by one. They might disappear en masse. We do have ways of saying that your app really needs to have your stuff stay, and ask the user, are you okay with my stuff staying? That actually is like the new persistent storage API that I think shipped in Chrome 55, where you could show a dialog to the user, this so-and-so wants to store data on your device, are you cool with that? And you click yes, and then Chrome will put you kind of last on the list of things that it might eject from the cache. So you have some options there if you need it. Sure. Yeah, no worries.
This is a quick one. If you are using a service worker, would you recommend not utilizing browser cache at all because it handles it, or
No.
what is your thoughts on the interaction between those two kind of battling cache?
So they shouldn't be battling. Jake Archibald, again, has like a really good blog post where he talks about proper HTTP caching and how it relates to service worker caching. I would recommend checking that out. I can send around the link. But basically the idea is you want things to work well for browsers that don't support service workers. There are browsers that don't support service workers. And if you're doing the right thing with setting cache headers, then let's say you include a hash in your file name and you set like a cache expiration of 1 year, then you could actually take some shortcuts and not have to use things like SW precache to do the versioning for you, and just rely on the fact that even though it looks like you're making a network request, it goes against the browser's cache copy, and you end up not having to use bandwidth doing that. So it's a pretty big topic, and I'll pass around like a link to like really good blog post that talks about it. Okay, so and I'm sorry, there's just so much to talk about here, so I'm going to try to go a little bit quicker with this. But please, I don't have to. I don't know if we're going to get kicked out of here or anything like that at a specific time. But I will keep talking. All right, so we're only up to option 2 at this point. So option 2 is what we're calling app shell. We've talked about this a lot if you've seen any of our previous Chrome teams presentations from the perspective of web apps, but you can, a content browsing app is a web app. So you could kind of use that same approach. The basic idea, so actually, well, let me just show you one example, and we could talk about what it's actually doing. So I'm going to again pull this open. So this is just like a React-based web app that I wrote. It's doing server-side rendering and then has client takeover and things like that. This is using SW precache. It's using SW toolbox, and it's kind of being a little bit more aggressive about the caching that's doing, because the app shell architecture lends itself to that a little bit more. So let me just show what's going on. The basic idea, though, is I'm going to go again to the app. So we can see over here, there's some things that are being pre-cached. These entries over here with the gear or request that comes from the service worker. So we have this /shell URL that's getting pre-cached the first time you visit the site and the service worker's loaded. And you could kind of take a look at the cache storage at this point, and we should see those entries too. So we have so over here, so we have some revision assets still, but we have this /shell URL. The basic idea for this is very, very much the same thing as a single page app. If anybody's ever built a single page app, the idea is you have this one kind of shell of your HTML and JavaScript and CSS that displays the generic interface, and then client-side code takes over and starts populating your view more or less with the actual content specific to that URL. In this particular case, it's using like React Router to like figure out, okay, you're on this URL, so I want to make this API call. That API call might be served from the service worker cache, in which case great, and it'll work offline. Or, in this case, we're pre-caching our app shell, but we're not like pre-caching like all the data. So this is like data for the iFixit API. So the very first time we go to a page, it ends up being requested from the network in this model. So you see over here, there's like, here's our, one of these is our network request. I don't know, there's a lot of requests here. But the basic idea then is that subsequently stuff ends up being stored in this runtime cache, and this is a little hard to see. But this is basically the URL for that like API call that I needed to populate it. So if I were to go directly to like this /shell URL, it's basically nothing. It's just like whatever is necessary to bootstrap your page. So in an app shell model, you take all navigations and you go to the shell initially, once the service worker is installed, and then kind of hands things over to the client page, and the client page is responsible for populating everything that's there. Making use of the fact that you might have your API stuff cached, you might have all your images cached, things like that. So if I were to go back over here and just go like over here offline, this all should work. Well, the YouTube part won't work, but the other stuff works, because I'm not caching the YouTube events. So that's the basic idea. And if you actually look at this request, what it is retrieving in this particular case is the HTML for my app shell, which is really, really empty. It's just this main with this like article. That's the React roots, more or less. So none of the stuff you see on the page was retrieved as part of that initial request for the HTML. It was all just populated after the fact. That's the basic idea. I'll send around a link to a talk that I gave that goes way deeper than that. Yes, I will get into that. All right, so that gets in the drawbacks section of this. All right, so the pluses though. So why would you care about this? Why would you want to do this? Contrast with the previous kind of messy updates. This allows you to have clean updates, depending upon what the specific, I guess, this demarcation is between what is part of your shell versus what is part of the dynamic content. Like if you have all the generic stuff, all the layouty stuff, all the header stuff in your shell, and then you load in the dynamic content, then you could cache your shell. You can make updates to your shell. You're just updating one HTML file that gets cached. You don't have to worry about expiring your entire cache, because theoretically all your dynamic content, in this case like all the API results we got from the iFixit API, that all stays the same. That's all valid. But I could suddenly change my headers, I could change all this other stuff without having to throw that all away. So that's a plus. That's actually a pretty significant plus. And it also means that things that I haven't navigated to before are still going to be fast. So basically, you're serving any arbitrary request for a URL. We'll get into routing in a second. But most requests for URLs, you're serving just with that app shell. So even pages you haven't visited before, you have the benefit of being able to go directly against the cache for that. Sorry, there's a question back there.
Yeah, aren't you essentially recreating Hugo or Jekyll in the browser using this app shell?
I will in step 3, in option 3. This is not quite. So what this basically is, though, it's building a single page app. And it's in this particular case, like I'm using React. So it's probably not the same tech stack that you would use for your static site generation. It's very similar to however you might build a single page app. Option 3, I'm going to really recreate Jekyll in the browser. So you'll see how that differs soon. Okay, so the other thing though is there's low overhead pre-caching. Because you don't have like all that duplicated HTML that you might have for each page, you can feel a little less guilty about being more aggressive about pre-caching. So in this particular case, it's like making API calls, and we're not going to cache the entirety of the API, but if you have like a site that has 1,000 articles, and each of the articles like a kilobyte of Markdown. Maybe you don't want to pre-cache every single raw Markdown file, and then or like every rendered Markdown into HTML snippet or something like that. But you can feel a little less guilty about pre-caching things because you're not wasting bandwidth to the same degree you would be with the first approach. So those are the benefits. Drawbacks though. All right, so the fact that you have to write a single page app, that I did not specifically call out, but yes. So you're writing a new code base, basically. You have something completely separate to maintain. Not everybody wants to do that. I don't blame you. If you're starting from scratch, though, if you're starting with a kind of like newer kind of project that doesn't have the same legacy constraints, you might want to consider going single page app for everything. This probably isn't the right audience for that, but you might want to consider it. There are other alternatives. We'll talk about that. But okay, so one of the other drawbacks, though, is that there has to be some routing logic in your service worker. So this is basically your way, unless your site is 100% served by this generic app shell, you need to be able to tell your service worker, for this subset of URLs, use the app shell. For this subset of URLs, just use some other caching strategy. And like the about pages, the contact forms, things like that, that most of these sites have, these are scenarios where you really don't want to use your app shell for that, because maybe you just have two completely different layouts. There's all these kind of scenarios where you could create 3 different app shells and like maintain the routing logic and say, like, if this is a request for /pages /blah, use this app shell. If this is a request for /contact /1234, use that app shell. But it gets a little more complicated and it's more overhead. And you also end up having to, so you duplicate some of the routing that might already exist client side in your single page app and not already in your server. You have to duplicate that again in your service worker, getting to trisomorphic routing, which is insane. And then you also just have to duplicate a lot of content potentially. So this kind of works well if you have snippets of HTML that is going to get dynamically inserted in your page. So you probably will have to create a new build process. So in addition to building those final HTML pages that have everything to be consumed by people who don't have a service worker or don't yet have the service worker installed, you're also probably going to have like a new build process that just spits out the, maybe if it's Markdown, gets converted to HTML, and then you have these partial HTML files that get served somewhere else. And you have to make sure that whenever you change whatever your canonical source of information is, that you rerun both those build processes and that things stay in sync, and it's overhead. There's more stuff that you need to think about and could potentially get out of sync. So that's a drawback. All right, option 3 though, this is what I'm personally most excited about just because I think it's the least explored. There are a few examples of this in the wild, but not as many. And this is what I was interested in for my own personal site. So I just have, my current blog is Jekyll, served on GitHub pages, nothing fancy by this audience's standards, I'm sure. But, I had a blog. I was like, okay, I would like to see what some other approaches are to make my personal blog work offline first. And the approach I came up with is using service worker templating. So what is this? Here's my blog, jeffy.info. Let's do the same deal. There's no internet connection. See, offline first, but you have to visit it once. Where's it work? Okay, so here we have our blog posts. And here's some stuff. This is just my new blog. I have other blogs going way back. But this particular blog has this number of posts. And so what's going on here? So there's a bunch of pre-caching going on. You can see actually here, so this is using SW precache, and it's like inserting that cache busting string in there when it's making its pre-caching requests, which is good. But I'm basically caching a bunch of partial stuff that directly corresponds to what my underlying Jekyll source has for templates. So let me pull up GitHub.com. All right, so here's kind of my work branch. It's very much the equivalent of what's over here. all these kind of partial stuff that gets stitched together during my Jekyll build, I am pre-caching over here. And in addition to pre-caching all that, I'm also pre-caching some content. So like I have the raw markdown content pre-cached. It's not that big. I think, I don't know, 2 kilobytes pre-cache that. So instead of having any final stuff cached, if I take a look at my cache over here, I have all these. I have my Jekyll config cache too, because I need to know what my site is all about, and I need all these kind of site level metadata. And I have all these partial layout stuff, and I have the markdown. And that all is great, but how do I get the final HTML? Like, what the service worker needs to do is give some HTML back to the browser in response to navigation. So the way you get the HTML, not surprisingly, is pretty much trying to do the exact same thing that that Jekyll does at build time, but you're doing it in the service worker. So this was a little messy. I kind of ended up with something that was a viable approach because it's running on my site right now. You know, if you take a look at the service worker, it's like this is like generated by SW precache. We're just like keeping track of all the hashes of everything, and has some runtime caching, but it's also doing like this import Jekyll behavior, blah blah blah, and it's basically saying, okay, I have this extra code. This code knows how to do Jekyll's templating. I would like it to run in the service worker for me. Taking all these primitives, all these smaller bits, piecing it together, spitting out a final page. This was made a lot easier because there is a Node port of the Liquid templating language. I would not write my own template parser myself. I'm sure there's probably people in the audience who have. That's great. I could not do that, or chose not to do that. So I found something that worked and like ran it through Browserify and got it, you know, even though it was meant for running the Node environment, was able to kind of massage it a little bit. I had a very light fork of it and was able to get it running in the browser within a service worker. And that wasn't all I had to do. I have to kind of, let me just pull up the code a little bit. So it's all broken out into these different files. So, you know, I have the pulling in like the Liquid node, but I'm also doing markdown parsing in the browser, and I'm doing all this stuff. Probably could have like taken the markdown and converted it and then published that as HTML, but I was like, I want to do everything that Jekyll's doing to the best of my ability. So what would that take? Sorry, is there a question?
Then it becomes very much browser dependent, right? If the browser doesn't have this ability, then the site breaks down, right?
No, because if you don't have a service worker installed, then it's just going to go to the network. So I'm not doing this as a replacement. My build process, and here I will show you what my build process is. And it's just all gulp based. I feel guilty because it's 2017 and I'm still using gulp, but you know, so I have like this bundler using Browserify, and it's taking my behavior import and it's generating blah blah blah. But my deployment process, and here's my service worker, and it's using SW precache to generate the service worker based on like all these file patterns. So basically, it's very flexible in that it's going to pick up like all of my templates from includes, all of my layouts, all my posts, blah blah blah, and at build time. But it's also like the process is do a clean, do a Jekyll build. This is going to do a full Jekyll build for me. Browsers that don't have the service worker, don't have service worker support, or browsers the very first time you visit the page when the service worker isn't yet installed, you still need to have that real HTML there. And that'll continue to work. It's just that once the service worker is in there, once you've got that proxy in place, this whole world opens up. So that's the general idea. All right, so yeah, all right, let me just talk a little bit about the benefits here, and then I'm going to dive into the code a little bit, and then maybe I'll say that's it, and you could grab me to talk later, because I'm conscious of everyone's time. All right, so same sort of thing with clean updates and low overhead pre-caching. That was the benefit of the app shell approach you also get with this approach. This is, in some senses, even cleaner updates, because if you just update your small head.html template, that's the only thing that needs to be re-downloaded. It's not like the full rendered app shell. It's just like really, really specific embedded validation. and lower bit pre-caching, tiny markdown files. You could probably get away with caching additional ones because you're not using too much bandwidth and you're not using too much storage. But anyway, but you don't need a single page app. So that's kind of key. What you do need is a really gnarly service worker. So I don't want to say that there's like no code to write, but you're writing a different type of code. And theoretically, I'll be able to release like this service worker Jekyll implementation as something you could just like install from npm, throw into your service worker, and you're good to go. And hopefully I will get to that point. It's not really at that stage yet where it's clean enough, but that's the goal at least. Drawbacks though, okay. You need a JavaScript-friendly templating system because you are doing the templating in your browser. So I lucked out in that Liquid node worked well. It's a lot of code though. So it's a little heavyweight. I think with all the dependencies for like doing the markdown stuff, or doing like dealing with front matter, dealing with all the templating, I think it's like 600 kilobytes uncompressed, and then it gets down to, I don't know, some fraction of that once you run it through gzip. But it does mean that there is this kind of like payload that needs to be transmitted to the browser as part of your initial service worker installation. Not super happy about that. I really think that could be optimized away, but I haven't had time to do that yet. If you happen to use a different templating language besides Liquid, I don't know if there's going to be a browser version of it. Like something like Handlebars, yeah, I'm sure there is because there definitely is. Other templating languages, maybe, maybe not. You kind of have to look into it for your specific use case. You do need to keep a lot of routing logic in your service worker. I'll talk about that in a second. And you do have the same problem with kind of duplicate content and routes where you end up having like the raw markdown and then the built HTML, and you have to make sure like if you update one, the other gets updated. If you have a build process in place, you don't really have to worry about that. It should take care of everything for you. But, you know, things might get out of sync theoretically if you don't have a good build process in place. All right, so that's the end of my slides. I was just going to take another second to dive into what the service worker for Jekyll rendering is actually doing. And then I will take general questions, and we could, you know, wrap things up and grab me and that sort of stuff too. But yeah, so the basic idea is we're pulling in a whole bunch of stuff that we need to basically behave like Jekyll, and initializing some stuff, and we're loading in like metadata. So one of the things I realized is that Jekyll knows a lot of metadata about like your list of posts in order to show like the front page and show the index of all the things. So we had to like, I had to do this additional thing where I was generating a JSON file that has like a list of all the posts for this to read. And using a lot of asynchronous code with a sync await, which makes this a little bit nicer, but it's basically like get the front matter for this given URL, and this will ideally go against the cache, but if there isn't anything, the cache will go against the network. It does, yeah. Excuse me, this gets Babelfied, or not, this is being transpiled, though, because, yeah, yes, because it's also inlining all this liquid. Liquid node in particular is very large. But yeah, it's basically like doing the same sort of stuff. Like honestly, I don't know very much about Jekyll. I assume that if you were to look into the Ruby source for Jekyll, it would be doing stuff that is somewhat similar to this. Maybe not. I kind of reverse engineered things like, okay, oh, I forgot how to pull in my metadata. I'll pull in my metadata like this, and until I got something working, basically. So I don't want to say that this is full fidelity with what Jekyll's doing, and I'm sure there are like template layouts that really could get this caught up. But from my side, at least, it all worked, which was nice. And yeah, it's just getting, so it supports different layouts by pulling in the specific layout based on what your front matter is, but there's also like this routing stuff over here, which is a little gnarly. But it's basically like saying if, and there's a regular expression for what my URLs are for all the stuff that is templated. If it matches that, then massage it a little bit and transform it into like a request for this markdown file and respond with that behavior. And if it's a request for one of these, then respond with like the main index page behavior, where it just shows that listing. And this service worker, if it doesn't match, if neither of these things match, then it's just going to fall back to the network. and that was a pretty safe default. So, yeah, that's pretty much what I wanted to cover. Thanks for bearing with me as I kind of just talked about this stuff. I find it really super interesting, and I don't think enough people are talking about it, so hopefully this will inspire some folks to take one of those options that's right for you and maybe think about making your site work offline first. If there are folks who work on static site generating frameworks and are interested in I would like to add tooling to my framework so that by default everybody gets offline first behavior, that is super, super cool, and I'm interested in talking about that as well. But yeah, any more questions right now? Sure. Yeah. Thank you.
Do you recommend a polished version for browsers that don't support?
No, it's really there is no true polyfill for getting a network proxy in the browser. There are general best practices to follow to make sure your site works well, whether you have a service worker or not, and some things like setting the appropriate cache headers for your sub resources and making sure that you have them all versioned properly with hashes and file names. Those all will help in terms of cutting out the network traffic that you make. But there's really no substitute that would let you do that first initial navigation going cache first in a safe way for most sites. So yeah, it's sure.
Great div, and it's great, really fantastic.
Cool, thank you.
Super cool. It's really interesting. I was just wondering if you
Can you repeat this question because?
Sure. It was a lot of praise for what I'm doing. So, yeah.
I was wondering if you have looked into, if you've really gone to do this, performance profiling and that sort of thing, and just straight static pages. You won't imagine that, especially if you throttle CPU, throttle network, it's going to be a pretty heavy load JavaScript parser
Yes.
page.
I
Just
have.
wonder if it's viable under those constraints.
Yeah, so for the service worker rendering in particular, I have not attempted to see what the impact is. And part of it is because I just know that it's not good code. I'm pulling in way too much from this templating language. And honestly, if I were starting from scratch. So let me give an example of my colleague Jake Archibald again. He has a similar blog that uses service worker rendering, but he is using a much lighter weight templating language for that. So I think he's done some kind of profiling of what service worker rendering in general gives you in terms of speed, but he's been focused a lot on streams, which I have not talked about at all over here. So one of the things that you can do if you want to get really fancy, unfortunately the templating, the liquid node stuff that I was using didn't support it, is to start streaming the response from the service worker right away instead of having to do the entire templating before you display anything. And I have a feeling that that would significantly improve whatever kind of latency there is for doing all the service worker rendering first. And that lets you have your head gets streamed to the page right away from the service worker, and then you render the body of your post, and then the body gets rendered as soon as that's ready. But in the meantime, you have something on the page already. So you can't stream a DOM update. This is only for the initial response from the service worker. Yeah, so I did not talk about streams at all just because I have not been able to get streams working, but that is one of the things that will make service worker rendering more viable in terms of performance. And using different dependencies than what I use would make it more viable in terms of the size of the service worker code. Yeah.
Your example on your GitHub is you have a React SW precache React kind of bootstrap.
Yeah.
Does it play nice with Angular 1 or 2, or is there any gotchas?
Yeah, so the question was about, I have some examples for React. Does this play nicely with Angular 1 or 2? So in general, the techniques for pre-caching and versioning things is completely agnostic to what framework you're using. That being said, if your framework is doing its own kind of routing and your service worker doesn't know about it, and those are in opposition to each other, it can get a little gnarly. So I don't want to say that you could just drop this into every single Angular 1 app, for instance, and have it just work. I will say that the Angular 2 team, and I talked to them, internally at Google, they're really thinking about not necessarily built on these same things that I'm talking about now, but how kind of their own solution for having a push button deploy service worker that will just work tightly coupled with their routing, tightly coupled with their strategies for like upgrading things on the fly. Like, you know, they're getting kind of like a little fancy with the options for doing, you know, you have a long-lived single-page app, but you update something. How do you make sure that update eventually propagates without there being a new navigation? So they're thinking about that a lot. I don't really have anything to tell you about like when that's production ready, but you can try those pre-cache and toolbox libraries with anything, including something that's generated by Angular, but there might be a little rough edge.
So you joked a couple times about you still using Gulp. Do you recommend a task runner?
No, I mean, I like Gulp. Like SW precache, so if you take a look at, I think you're referring to when you talked about like the React stuff. So I have this like create React PWA thing.
PWA, that's right.
So I don't know if folks in this audience have played around with Create React app, but it's like a really nice React single page app framework. And I was like, okay, so what would it take to take that output and make it into like a progressive web app, which is basically having a service worker to do offline and having like some manifest information. And it wasn't that different. So it's like, what I ended up doing here was just sticking at the end of the build process. There's a command line version of SW precache. So like I showed it being run from the Gulp process. You could also run it from the command line and pass in this config file as a JavaScript config file. And it's just like you run your full React build, you have all your final HTML, you have all the assets, everything's there, and then you just run SW precache and say, go at it, generate your service worker that knows about all the versions of those files after the fact. So that's just one way of adding in SW precache at the end of an existing build process as just like npm command line scripts. If you want to do that, it's probably the easiest way to use it. Cool. Should I cede the stage?
Yeah, thank you, everyone.
Cool. Thanks.